couple of things here, guys, just before you get started on this quiz. Okay, make note of the types of graphs there are in each question. Okay, they are not the same kind of graph. Okay, in the first graph, it is a velocity versus time graph. Okay, and the second graph is a position versus time graph. Okay, so make sure you're aware of that. And this is measured in position, meters, north. Okay, the N stands for north, so that graph is showing you, okay, how far north or south or whatever it is going. Okay, so I would say, positive would be north and negative would be south. Just something to keep in mind, right, when you're putting your answers together for both of those. All right, now you won't be able to see both questions at the same time, so I'll leave question 1 up for a while, and then I'll roll it up so you can see all of question number 2. Okay? All right, so if I want to get displacement from a velocity versus time graph, okay, I have to think about this. In order to get displacement, if I have velocity and time, okay, I would have to look at how would I manipulate this formula to get it. I'm not going to use this formula, but I have to think about how would I use these 3 things to get, or these 2 things here, to get D. The answer is I would multiply them together. Well, if I've got velocity here and time here, I should multiply them together. That means finding the area underneath this line. That will tell me the overall displacement of this object over the entire trip. Okay? All right, so here's what we need to do then. We need to go 60 times 10 over 2 for our first triangle. Okay, because it is 60 high, okay, by 10 wide. 60 times 10 is 600, over 2 is 300. Okay, our next one is 60 times 5, which is also 300. Okay, and then our last one is 60 times 15 over 2, and I believe that's 450. Okay, and then we add them all together. Okay, so if they have some area calculations, you can give them 1 mark for each area calculation. Okay, and then 1 mark for the final answer, 1,050 meters. And that should be positive, but I'll let it go if it doesn't have the positive on because the graph didn't have positives on it. Okay, questions on that one? How many people said the overall displacement was 0? Okay, again, that's why I pointed out this is a velocity versus time graph. You cannot read position off of this graph. It doesn't show it. Okay, you can calculate displacement, but it doesn't show position. Then I have no idea how they got the right answer. Then he wasn't finding the area of this triangle. Okay, if he went 6 times 10, it's not right. Right? He didn't get the right number if he went 6 times 10. Okay. Second one is a position versus time graph. So if I want to find the average velocity is always total displacement over total time. Well, displacement from a position versus time graph is final position minus initial position. Well, the final position is -20, the initial position is 0. Therefore, the overall displacement is -20 meters. So you can give them a mark if they recognize they had to use V equals D over T. Give them a mark for plugging in -20 over 9 seconds because, of course, that's how long this all took on our graph. Okay, and their final mark, -2.2 meters per second. It has to be because the displacement is also negative. Now, I will also accept if they wrote south, because that would also be right. The graph, after all, gives the meters in north, and negative north is south. All right? If they do not have the south, the answer is wrong. They can have the other 2 marks for work, but they must have either a negative or a south on there in order to get the answer mark. Okay? So, whole thing is out of 7. Please give them a mark out of 7, let them see it, and put it in the box. All right. So, a couple of things we need to know about movement and energy first before we talk about acceleration. Okay? And that is this single word, inertia. Okay? Inertia means the tendency of an object to continue doing whatever it's already doing. All right? We also call it Newton's first law. We'll talk more about that when you get to Physics 20 if you take that. Okay? Essentially, what inertia is and what a Newton's first law says is this. This desk will stay right here unless somebody moves it. Not rocket science, right? Okay? But that's what inertia is. Unless there's some force out there that isn't balanced, everything is going to continue doing what it is already doing. Right now, on this desk, there are essentially two forces. The force of gravity pulling it down, and the force of the floor pushing it up. Right now, those two forces are exactly the same. They're in opposite directions. They're exactly the same. As a result, the desk doesn't move. Okay? But as soon as I pull on it, now it does. Now there's an unbalanced force. Gravity and the force of the floor are still there, but there's suddenly a pulling force forwards. It's not balanced by anything else, so the desk moves towards me. Okay? So inertia describes any situations where there are no unbalanced forces. Okay? By the same token, if you had something moving at a constant speed, okay, it would mean that there were no unbalanced forces acting on it. There certainly would be forces on it, but none of them are out of balance. That's why it continues to move at a constant speed. That's why if in space you were ever to get separated from your ship and not have a, like the little maneuvering jets, you would float away forever, because there would be no forces to stop you. Flapping your arms and legs in space is only undignified. It will not save you. Okay? There is nothing against which to push in space. In fact, flapping your arms and legs on Earth and falling through the air doesn't do you much good either. Okay? But in space it does even less. All right? Without something to push against, you have no way to change your velocity. All right, now acceleration. Acceleration happens when there's a change in velocity. All right, so if I'm standing still and then suddenly I start running, okay, then my velocity is changing. It goes from 0 to some other value. Everybody with me there? Okay, so acceleration very strictly is a change in velocity over time. All right. Okay, so meaning of average acceleration, okay, is best exemplified by a plane at takeoff. Okay, we call that acceleration also uniform acceleration. The velocity of the plane changes by the same amount each consecutive second. Okay, gives us a nice velocity versus time graph. Okay, that looks like this. All right, that's uniform acceleration. Okay, why don't we use a car accelerating away from a stoplight as an example of uniform acceleration? Well, no, I mean, if it was perfectly uniform, it would look like this. Okay? But do you accelerate more in a different gear in your car than you would in others? Okay, you do. Right? You accelerate most in first gear, and each consecutive gear after that, your ability to change speed decreases. Okay? So if you're looking at a velocity versus time graph of a car accelerating, it has a tendency to look more like this, and it tends to flatten near the end, because as you get into the higher gears, it's harder and harder for your car to accelerate. Okay? You've probably noticed that if you've ever been on the highway at like 110 and you needed to pass somebody, okay? If you put the pedal to the floor, your car shifts down a couple of gears if you have an automatic. Okay? It shifts down a couple of gears to give you the extra jump you need. If you drive a standard and you leave it in like 5th or 6th, the car just kind of lags, okay, and it doesn't really change speed very well until you shift gears lower. All right. So we use a plane as an example because it's much more uniform. Planes don't have gears; they just have the throttle, and when pilots want to take off, they just push the throttle all the way to the most forward position, and the thing rockets down the runway. All right. Everyone, follow me there. All right. So our formula is this: acceleration is the final velocity, VF, minus the initial velocity over time. Okay? Or in other words, the change in velocity over the change in time. Now this is probably the first time you've seen the symbol for delta. Okay? That's the triangle there. Okay? Delta means change. Okay? Delta is the Greek letter D, but it means change. Anytime you see delta, delta means final minus initial. So if acceleration can be calculated by taking final velocity, subtracting initial velocity, and dividing by time, is that off of this graph? Okay? If this graph is showing velocity and time, okay, then if I pick 2 points on this line, this, which we would call y2 in a slope calculation, could also be considered to be VF. Whereas this, y1, could also be considered to be VI. And then, okay, this here would be the change in time. So is this formula really just a slope calculation from a velocity versus time graph? Yeah, yes, it is. All right. Anytime you want to find the average acceleration of something, you take the final velocity, subtract the initial velocity, that gives you the change, you divide it by the time. Now, it gives you weird units when you do that. Okay? The units we get when we do that. Okay? We're dividing meters per second by seconds. Okay? So meters per second divided by seconds. Now, if you're going to divide fractions, what do you do with the fractions when you're going to divide them? Anybody remember from like grade 8 math? Yeah, denominator to numerator, or you reciprocate this and multiply. Either way, what you end up with is this. Meters per second times 1 over seconds. Okay? Now, what's meters times 1? Meters. What's seconds times seconds? Seconds squared. Okay? So the units for acceleration are meters per second squared, which is another way of saying meters per second per second. Right? It's telling me how much I change my velocity by every second. How many meters per second faster or slower am I going each second? All right? Everybody with me on that part? Okay. So let's look at this first example here. All right, so I've got this plane, okay, and over a 29-second period, it goes from 260 kilometers per hour to, or sorry, it goes from 0 to 260 kilometers per hour. All right, so if I want to calculate its acceleration, I would go 260 kilometers per hour minus 0 kilometers per hour divided by the time, 29 seconds. Is it okay in this case for me to divide kilometers per hour by seconds? Actually, it is in this case. It's okay for me to say the acceleration of this plane is this many kilometers per hour per second. Right? It's still a valid unit of acceleration. We never use it, but it's still valid. Okay? Whenever I give you an acceleration question, I'll give you everything in meters per second. All right? You won't have to worry about it. But in this case, right, we would get 260 over 29, and that would give us the acceleration of the plane in kilometers per hour per second. So we know how many kilometers per hour faster it's going each second, right? Which would allow us to figure out what speed the plane would be going, okay? Maybe in another minute and a half, okay, or something like that. All right. Now, sorry, this is what I just showed you a minute ago, okay? The units thing, forgot I had that on there. Okay, manipulating this formula. If I want to manipulate my acceleration formula, right now it's set up to solve for acceleration. Here is also the point where the triangle will fail you miserably. Okay? Now the triangle will let you down. If you have still been relying on a triangle, okay, your pie in the sky days are over. Okay? You will now have to do algebra. Right? Believe me, I'm going to save you from a life of torment by teaching you algebra. Okay? Now, I want to solve, let's say, for time. How would I change this formula to solve for time? Switch a and t, or multiply both sides by t and divide both sides by a. All right, everyone with me there? Don't bother writing down every single manipulation of this because you won't be able to take those with you on the test. Okay? It's better if you just figure out how to do this. All right. What if I want to solve for VF? Well, I can't minus it yet, because when I manipulate stuff, when I manipulate an equation, I still have to obey the order of operations rules. All right? In order of operations, you do parentheses, exponents, multiplication and division, and then addition and subtraction. You guys follow me there? Is that ringing a bell? Right? So the first thing I need to do then is move t back. Whoa. Come on. Is move t back over to here. All right? So now I have t times a equals VF minus VI. Now, how do I get VF by itself? How do I move VI to the other side? Add it. Right. Guys, there's only two rules in algebra. Okay? What you do to one side, you do to the other. And if you want to move something, you do the opposite. Okay? If I'm subtracting right now, I want to move it, I have to add. All right? So I'll take my VI. Okay? I'll move it over to here. And add it. It's like I've done this before, right? All those little pieces waiting. Okay, so VI plus t times a equals VF. Now, okay, in order for maybe to make that make a little bit more sense, okay, right now t times a equals VF minus VI, which our other formula said is known as the change in speed, okay, or the change in velocity. So if I know what the change in velocity equals t times a, let's say I know how fast I was going at the beginning. Okay? If I know how fast I was going at the beginning, I would add the change to figure out how fast I'm going at the end. Does that sort of make sense? Right? It's like this. If you start out the day with $5 in your pocket, okay, and then you go to work and you make $10, how much money do you have at the end of the day? You started out with 5, you made 10. How much do you have now? 15. Your change in money over the day was 10, right? You took the change in money and added it to what you had at the beginning of the day, and now you have your final amount of money. That's exactly what we did here. We took our initial velocity and added how much we changed our velocity by. That gave us our final velocity. All right? Now, the other way that this might work, what if I want to solve for VI? Well, then that would be like this situation. It's the end of the day. You have $15. Okay? At work, you made $10. How much money did you start the day with? $5. Okay? How did you figure that out? You took the final amount of money and you subtracted how much money you made during the day. And that gave you how much money you started with. Okay? So logically then, that's what we would do here. Okay? I would take VI over to this side. Okay, by adding it, and then I would subtract this. VF minus t times a should give me VI. Everybody all right with that? It'll take a little practice, but you'll get the hang of it. Okay, just got to do a little bit of manipulating of algebra here. All right. Why is that not staying together? Okay, so just quick manipulation stuff there. Now, let's try a few examples. Write this one down in your notes. Okay, you don't have this one in there, so write this one down. Sprinter starts from rest. How fast are you going if you're resting? 0. Okay, anytime you see the word from rest or comes to rest, okay, then either VI or VF is 0. If it starts from rest, VI is 0. If it comes to rest, VF is 0. Right? So in this case, it starts from rest. Okay? Reaches a velocity of plus 16 meters per second in 4.5 seconds. What is his acceleration? Well, first thing we should do, as we do with any problem-solving question, is write down our givens. All right? Started from rest. VI equals 0 meters per second. Okay? Reaches a velocity of 16 meters per second. That would be VF, 16 meters per second. Right? And that took 4.5 seconds. What does seconds measure? Time. T. Right. What is his acceleration? So I'm looking for A. Here's why we make you write down your givens. I'm going to give you a formula sheet today, and it's going to have many formulas on it. Writing down your givens will allow you to decide which formula to use in case you have no clue. Now, if you see the word acceleration, you should probably use the formula labeled acceleration on your formula sheet. But if you're lost, okay, you will find that there will be only one formula that contains the 4 things in the question. All right, so the only formula on your formula sheet that has these is this one. A equals VF minus VI over T. Okay, I'm asked to solve for acceleration, and that equation is already set up to get it. So I don't have to manipulate, I just need to plug the numbers in. Okay, so that'll be 16 minus 0 over 4.5. All right, so we're doing that on our calculator here. Okay, so we'll have 16 divided by 4.5. All right, so our acceleration then is 3.6 what? Meters per second, or meters per second squared. Okay? Don't let that squared fool you. You don't need to square your number. Okay? For some reason, a lot of people think they have to do that. Okay? The meters per second squared is just the units. It doesn't mean to square anything. Okay? All right. Does that one make sense? I'll give you guys a few minutes to get it copied down here, and then we'll go on to the next one. All right. Here's our second one. How long will it take? Okay, if a question asks how long will something take, what are they asking you to calculate? Time. All right, so time is my unknown in this question. How long will it take a jet to accelerate from rest, VI equals 0, to 85 meters per second, positive 85, okay, at a rate of positive 22 meters per second squared. Okay, meters per second squared are the units for acceleration. All right, so we're looking for t, and I have the other 3 parts of that formula. All right, so if I look on my formula sheet, again, I'll find there's only one formula that has all 4 of those things in it. Now I need to manipulate for t. So to do that, I multiply both sides by t, and then divide both sides by a. All right, so there's my new formula. T equals VF minus VI over a. Oh, plug in my numbers, and that'll be positive 85 minus 0, all right, over positive 22 meters per second squared. All right, so punch that into our calculator. All right, we get that that's going to take 3.86 seconds. Okay. Does that make sense? All right, I'll give you a couple minutes to get that copied, and then I'll go on to the next one here. Okay, so on this one here, okay, we've got what is the final velocity of a race car if it starts at 15 meters per second, okay, accelerates at positive 7.2 meters per second squared for 6.5 seconds. All right, so they're asking us what is the final velocity. So that's VF. That's what they want us to know. Okay, so VF is a question mark. It starts, okay, at 15 meters per second. So that's VI. Positive 15 meters per second. Thing to remember, acceleration is a vector quantity, guys. All right? Acceleration can be positive, meaning your velocity is increasing, okay? Or it can be negative, meaning either you are slowing down or you are accelerating backwards. Okay? One or the other. Okay, in this case, the acceleration is positive 7.2 meters per second squared, and the time is 6.5 seconds. Right, so there's the things that we know. So if I want to solve now for VF, I've got A equals VF minus VI over T. All right, so first thing I want to do, multiply both sides by T. Okay, so it's gone. Now I have T times A equals VF minus VI. So if I want to get VF by itself, I need to add VI. I always have to do the opposite. Right? So if I add VI to both sides, it cancels. And now I have VI plus T times A equals VF. Now it's just a matter of plugging in my numbers. All right, so positive 15 plus 7.2 times 6.5. All right, so the final velocity of this race car is going to be 61.8 meters per second, and that's got to be positive because that's the direction given to me in the question. Okay. Give you a minute to get that one written down. All right, so last manipulation of this formula. How fast was a boat traveling initially? So we're looking for VI. Okay, if it accelerated to positive 30 meters per second, so that's VF, at a rate of positive 2.6 meters per second squared for 8.9 seconds. All right, so there's all of my givens. I've got to solve for VI. Okay, so A equals VF minus VI over T. So I'm solving for VI this time. Again, I got to obey order of operations. I got to do my multiplication and division first. Okay, so I'm moving T over first. Okay, and then I want to get VI by itself, but I don't want it to be negative. If I move VF over here, okay, I'm going to be solving for negative VI, and I'd prefer not to do that. So I'm going to add VI to both sides. Okay, that's going to give me VI plus T times A equals VF. Okay, well, that's the formula we used the last time. Right? Now, looking at this, I have VI plus T times A. So can I just subtract T times A over to the other side? I can. Because if I was doing this equation the way it is, I would do T times A before I added to VI anyway. So T times A is really just like X. It's just a number. Okay, so I can subtract it over to this side. So I'll subtract T times A from both sides, and now I've got my final velocity minus the change in velocity gives me the initial velocity. Okay, so now I can plug in my numbers. All right, so VI is going to equal positive 30 meters per second minus 8.9 seconds times the acceleration, which was positive 2.6 meters per second squared. Okay, so there's my equation. When I plug it into my calculator, 30 minus 8.9 times 2.6. Right, so the initial velocity of the boat was 6.86 meters per second, and that was forwards or positive. Okay. Okay, there you go. Caroline. It would say how fast is it going at the end, or it would actually maybe say what's the final velocity, or how fast is it going after something. Yeah, all of those would indicate we're looking for a final velocity as opposed to an initial. Okay. All right, anyone need that one anymore? Dom? For acceleration, not usually. Okay, usually it's just a one-part thing. All right, now here's kind of the step up. Okay, this is where acceleration being a vector quantity becomes important. All right, if I throw something up in the air, which way is it accelerating after it leaves my hand? Down. All right, that's why it comes back. So in a case like that, my acceleration is in a different direction than my initial velocity. Okay, and my equation has to reflect that. Okay, so for this question here, this is a good example of that. So I would copy this one down. I've had a question like this on pretty much every unit exam ever. All right. So a ball is rolled up a hill at 4.5 meters per second. So if you roll something up a hill, as soon as it leaves your hand, which way is it accelerating? Down the hill. Okay, so it's important to read a question carefully. All right, so we know VI is, we'll say, positive 4.5 meters per second. It accelerates down the hill at 2.1 meters per second squared. All right, so that means negative 2.1 meters per second squared. Okay, what is the velocity after 3.5 seconds? So what, like I was saying before, what are we looking for if it's after a certain time? We're looking for VF. All right, so VF is our question mark here. All right, so we set this up, same as we did before. A equals VF minus VI over T, and we do our manipulating. We multiply both sides by T, and we add VI to both sides. Okay, that gives us VF. Now, when I plug in my numbers, this is where recognizing that A is backwards or negative compared to the initial speed here is important. So, positive 4.5 plus negative 2.1 times 3.5. Okay. Negative 2.85 meters per second. Which way is the ball going after 3.5 seconds? Down the hill. Okay, which is what happens when you roll something up a hill. It eventually comes back to you. Okay, and that's exactly what this question is illustrating. Now, in a question like this, you were not given positive and negative as vectors in the question. So when you make your final answer, should you leave it as negative or should you use the directions given in the question? The answer is use the ones in the question. I'm not going to leave this as negative 2.85. I'm going to say that the final velocity is 2.85. Well, that's messy. 2.85 meters per second downhill. Right? Make sure always in your answer your vectors match what you were given in the question. Okay. All right. Questions on that one, Dom? I would probably accept it, but in Physics 20 I wouldn't. Okay? Because down to me, straight down. This is down the hill, so that's an angle. Right? They are different things. Okay, anyone need that one anymore? Okay. No triangles, guys. It won't work anymore. Okay? It's simply going to fail you now. All right, so make sure you're doing the algebra here. All right, I'm going to do one more example before you get started on that sheet. Now, I just gave you the formula sheet. The formula sheet is to this physics unit as your periodic table was to the chemistry unit. You need it every single day. If you don't have it, it will be like you're missing a hand. Okay? You're going to want it all the time. It is essential for you. So, maybe put it in one of those plastic transparent page protector things so that you always have it. All right? Now, another thing to be aware of, because some people make this mistake, and they write every manipulation of every formula on their formula sheet. And then, when the exam comes and I don't let them use their formula sheet anymore, they're dead. Okay? Make sure you don't fall into that trap, because if you do, you won't practice your algebra, and then on the test, you're going to have to do algebra, and you won't know how. All right? If you're having trouble with the algebra, come in and see me, and I'll help you. Okay? All right. So another one here. Object is thrown up in the air at an unknown velocity. Right? So which velocity do we not know? VI or VF here? VI. Okay? It's in the air for 6.5 seconds, and its final velocity is 2.4 meters per second down. Acceleration due to gravity is 9.81 meters per second squared down. Okay? That number is a number you'll use all the time. It is on your formula sheet. The acceleration due to gravity is negative 9.81 meters per second squared. What was its initial velocity? Okay? So, VI is unknown. Okay? VF is negative 2.4 meters per second. Acceleration is negative 9.81 meters per second squared. And the time is 6.5 seconds. All right? So, same as before. All right? A equals VF minus VI over T. Okay, so if I'm manipulating, I multiply both sides by t. Okay, I'm going to add vi to both sides. Okay, and then I'm going to subtract t times a. Okay, so that I get vi equals vf minus t times a. Okay, and then I'm going to plug in my numbers. So vi equals negative 2.4 minus negative 9.81. 9.81 times 6.5. Okay, so when we punch that into our calculator, okay, we'll have negative 2.4 minus negative 9.8. Whoop. Minus negative 9.81 times 6.5. Okay, which way do you suppose this thing was thrown? Up or down? Yeah, it had to be thrown up. Actually, the question says it was thrown upwards. Does our answer agree with that? Yes. However, it is physically impossible for anyone to have thrown it at 61 meters per second. Okay? A major league pitcher might throw in the neighborhood of 38 to 40 meters per second. Okay? If you think about that, if you're standing at the plate of a major league game and a guy throws a 100-mile-an-hour fastball at you, you have like, what, less than a second to decide whether you're swinging or not. Okay? In fact, you pretty much got to make up your mind before he's done his wind-up, or you will be swinging and the ball will already be in the catcher's mitt. Okay? So if you ever thought those guys had it easy and the game looked easy, okay, you haven't stood at the plate and watched that ball come at you at 100 miles an hour. Right? If it hit you, it'd leave a 3-foot hole coming out. Okay? All right. All right, so you got that worksheet there in front of you guys. Let's get to work on that. Okay, and if there are ones that give you trouble, we'll go over them together. Should have mentioned it. Okay, guys, sorry. First question, right off. You have to convert kilometers per hour to meters per second. Okay, in order to do that, just divide this number here by 3.6. Here's why. Okay, it's called a compound conversion. If I've got kilometers per hour and I want to convert to meters per second, I have to convert both units. Okay, so what I do is I take, first off, I'll change my kilometers to meters. So that means I need to multiply by this conversion factor. How many meters in a kilometer? 1,000. So there are 1,000 meters in each kilometer. So first thing I'm going to do is multiply kilometers by 1,000. That'll give me meters. That makes sense. Okay. Then the other thing I have to do is convert the hours to seconds. Well, in 1 hour, there are 3,600 seconds. Now you'll notice by doing that, I have kilometers on the top and on the bottom. So they cancel. I have hours on the bottom and on the top. So they cancel. So whatever I had in kilometers per hour, it was 140. Okay, I multiply it by 1,000 and then divide by 3,600, which is the same as saying 1,000 over over 3,600, which is the same as 1 over 3.6. You guys follow me there? If I divide both of these by 1,000, I get 1 and 3.6. So 140 times 1 divided by 3.6. So take your 140, divide by 3.6, and you've got your meters per second. Okay? So that's what part A is. Part A is converting that 100 kilometers per hour, or sorry, 140 kilometers per hour into meters per second. Okay? Everyone with me there? So you're not going to be asked to do that on a test ever. Okay? Just so you know, it's divide by 3.6, you get kilometers per hour to meters per second. If you want to convert meters per second to kilometers per hour, multiply by 3.6. Okay? Okay, let's just go over number 1 together here, guys. Here's something we have to be aware of. Reading the question carefully is really important here in terms of figuring out which is VI and which is VF. Okay, so it reaches the straightaway going 38.9 meters per second and accelerates at a rate of 3.5 meters per second squared for 6.2 seconds. So it was already going this fast, and then it accelerated. So is the 140 or the 38.9, is that VI or VF? It's VI. Okay, so we know VI is 38.9 meters per second. We know the acceleration is 3.5 meters per second squared, and we know the time is 6.2 seconds. We're looking for VF, right? So you do your manipulation of the formula and solve for VF. Okay? All the answers are on there, guys, in bold, so you can check your work as you go.